Welcome to our first lesson of solving systems of linear equations. Today we're going to look at solving these systems using the graphing method. A linear system is made up of two or more equations of lines that are usually related by some real-world scenario. Here's an example. Let's say that Sarah spent $23.40 on music that she purchased in iTunes. Some songs were 99 cents, some were $1.29, and she bought 20 songs altogether. How many of each type of songs did she buy? So we would use two variables to represent each type of song, the 99-cent song and the $1.29 songs. The number of songs would be represented by saying x plus y equals 20. So the number of 99-cent songs plus the number of $1.29 songs. Altogether, we know she purchased 20. And then there'd be another equation for the cost. So that would include the cost times how many of each kind that she bought. So 99 cent times how many she bought, $1.29 times how many of these songs she bought, for a total of $23.40. So this is a very quick example of what a linear system would look like. So these two equations here form our system. And so one might say, okay, so now solve and find how many types of each song that she bought. So there are a couple of prerequisite skills that you'll need in order to be successful with this method we're about to try. If you need extra help on these two skills, please see me for extra help. So the first skill would be being able to rearrange an equation. We will need to do that to get y alone in order to graph, because we're going to use the y equals mx plus b method for graphing on a coordinate plane. So an example here, if this is not already arranged to get y by itself, you would have to do it yourself, and you're going to have some of these that you will have to do before graphing. So the first thing you would want to do is bring over the x term. Try to get in the habit of lining up in this format right here with the mx term before the b term. So then this would first look like 3y equals negative 2x plus 4. And then to totally isolate y, we have to divide out this multiplier. So now our equation would end up looking like y equals negative 2/3 x plus 4/3. Just a side note, you're always going to want the slope to definitely stay a fraction. When you actually do graphing, however, the b value probably is easier to look at as a decimal. So decimal okay here, but always a fraction for your m value. The next prerequisite skill, which hopefully you've acquired in Algebra 1, would be graphing your lines on a coordinate plane. So when you're graphing, a couple things to note is after you've got your y alone, B is where you start on your y-axis. So it's a point, your first point on the y. And then your m is your slope. So that kind of is done in two steps. The top number tells you to go either up some blocks or down some blocks. Down would be for your if there's a negative. So in this example here, I'd be going down 2 units. And then the denominator is always telling you how far to go to the right. So you would have to do the going up and down and then going to the right, and then you put your next point. There are three possible outcomes for our solutions. So before we take a look at our first example, here's in general the three different scenarios. You might have one solution where the two lines cross and meet exactly at one point. If that's the case, then you've got to give an answer, which would be the ordered pair at that spot. Another type of answer would be if the lines never cross because they're parallel, we would say that there's no solution to the system because they don't cross or meet at all, so no solution. If the line, if the two lines actually graph one on top of the other, it means that all the points are in common, so infinitely many solutions is possible for that system. So here notice your b and your slope would be actually identical. Here, for parallel lines, just your slope would be the same. They would have two different b values on the y-axis. So if everything's the same in the equation, that would be infinitely many solutions because of all the points being in common. Let's say that someone claims a system has already been solved and we have an ordered pair or we have several ordered pairs. How do we know if it actually is a solution? You can test the point or points by actually substituting the x and y value into both equations, simplify, and see if your equation proves that left and right side equal each other. So here's our first example. Is 2, 3 a solution for the system? So being very clear on your x and y values, you're going to take the ordered pair and replace those in the equation. And for the first one here, I've got 10 minus 7 after you simplify. So 3 equals 3 is a true statement, which means the ordered pair works for this equation. It needs to also work for the other equation to be the solution to the entire system. Because remember, the two equations together make a system. So I'm doing a little bit of simplifying here. And we've got negative 12 equals negative 12, which is a true statement. So this tells me the ordered pair also works for the second equation, which is a sign that it is a solution to the entire system. So it has to work for both equations. So this is kind of just a test if you already know or are given the solution. If you have to go through all the work and find the solution and you want to take that extra step and go above and beyond and check it into both equations, that would be wonderful. But I don't require you to do it. Please take a minute to record this process. I kind of narrowed it down to a 3-step process on solving linear equations graphically. Step number 1 is to graph all the lines in one graph, making sure you're already in y equals mx plus b form. Step 2 would be once you have the graph, you're going to identify the ordered pair where the lines intersect if they do intersect at one point. If they don't intersect, then you're going to respond with no solution. And if they overlap each other, then your response or your answer is going to be infinitely many solutions. The first example that we'll do together. Y equals negative 2 and 4x minus 3y equals 18. We're asked to solve the system graphically. The first thing you're going to want to do is make sure that both equations are in y equals mx plus b form. The first one already has y alone. The second equation will have to be rearranged to get y alone. As you're getting y alone, it'll probably take you a couple steps to get there. Always keep in mind that if you have a negative and you're dividing by another negative value, that will turn positive. So that happens here with my 4/3 because I subtract 4, then I divide by negative. So the negative over negative becomes a positive 4/3. And of course, 18 divided by negative 3 is a negative 6 value. So graphing the y equals negative 2 means we're finding negative 2 on the y-axis and then keeping in mind that that will be a horizontal line for y equals negative 2. And a ruler always works nicely with graphing these, but I don't have a ruler at the moment. The second equation begins at the b value negative 6 on the y-axis. That's this point right there. So you're going to want to plot that point and do your slope, which tells you to go up 4 values over 3. So up 1, 2, 3, 4 over 1, 2, 3 gives me my second point. And pretty much what you're going to want to do is carry that slope over and over again until you meet up with your line. And sometimes you have to reverse the slope if your line is on the other side. And then you connect the points, ideally with a ruler. And then the very last step, if you recall, is identifying the solution. So here we're crossing at one point, which is this point right there. So we report the answer as an ordered pair. So our x value is 3, and our y value is -2 in parentheses, and that is our solution. Please take a minute to record this quick summary of solutions when you're graphing. So the one solution on a graph, you will actually see the two lines cross at exactly one point. So your job is to finalize the problem by reporting the x and y values, or the coordinate for the intersection of the two lines. If there's no solution, remember that the lines are parallel, so they won't cross. If you can remember how to tell that the graph will be parallel or not cross before you even make the graph, because you can tell by the equation, then it's fine that you don't actually graph, but you just say that there's no solution because the lines are parallel since the slopes are the same value. If you can remember that, that's great. Otherwise, graph the two lines and then say that there's no solution. Infinitely many solutions are when the two lines will coincide or overlap one over the other. That means they're the same line. So in terms of the equation, remember that means that the slope is the same and the b values are the same. So even before you graph, you could determine that these are the same lines just based on the equations. So if you can detect that even before you graph, that's wonderful. On paper, you'll have to write that they're the same line, so there's infinitely many solutions. Okay, that's it for this lesson. Thank you for watching, and let's get ready to practice.